The role of AutoCAD, Solidworks, and Ansys in mechanical engineering. In the field of mechanical engineering, software tools are essential for design, analysis, and simulation. Among the most crucial of these tools are AutoCAD, Solidworks, and Ansys. Each of these software platforms plays a distinct role in the engineering process, offering unique features that cater to different aspects of mechanical design and analysis. AutoCAD is widely recognized as the premier drawing tool in mechanical engineering. Its reputation as the best drawing tool is well-deserved, thanks to its unmatched precision and versatility in creating 2D and 3D designs. AutoCAD is an industry standard for drawing, enabling engineers to produce detailed and accurate technical drawings essential for the manufacturing process. These drawings are the foundation upon which mechanical components and systems are built, making AutoCAD indispensable for any mechanical engineer. Moreover, AutoCAD's interoperability with other design software ensures that designs can be easily shared and modified across different platforms, streamlining the engineering workflow. Solidworks is another cornerstone in mechanical engineering, particularly known for its capabilities in parametric modeling, assembly creation, and sheet metal work. Solidworks excels in parametric design, allowing engineers to create models based on specific dimensions and constraints that can be easily adjusted as needed. This feature is invaluable during the iterative design process, where changes are frequently required. Additionally, Solidworks is highly effective in managing complex assemblies, enabling engineers to visualize and analyze the interaction between different components within a mechanical system. This is particularly important in industries such as automotive and aerospace, where precision and functionality are paramount. Solidworks also provides robust tools for sheet metal design, allowing engineers to model sheet metal parts accurately and efficiently. Furthermore, Solidworks offers advanced features for animation and motion studies, enabling engineers to simulate the movement of parts within an assembly, predict potential issues, and optimize the design before any physical prototypes are made. Ansys stands out as a powerful tool for simulation, particularly in the areas of stress and strain analysis and determining the factor of safety. Ansys is renowned for its advanced simulation capabilities, which include finite element analysis, FEA, and computational fluid dynamics, CFD. These tools allow engineers to perform detailed analysis of mechanical components and systems, predicting how they will behave under various conditions. For instance, stress and strain analysis in Ansys helps engineers identify potential failure points in a design, ensuring that products are both safe and reliable. The software's ability to calculate the factor of safety is particularly critical in industries where human lives may depend on the reliability of a component, such as in aerospace or automotive engineering. Ansys provides engineers with the tools they need to optimize designs, reduce material costs, and improve overall product performance. AutoCAD, Solidworks, and Ansys are indispensable tools in mechanical engineering, each offering specialized capabilities that address different stages of the design and analysis process. AutoCAD's unmatched precision in drawing, Solidworks' robust parametric modeling and assembly management features, and Ansys' comprehensive simulation tools form a powerful trio that enables mechanical engineers to create, analyze, and optimize designs with confidence. These tools not only enhance the efficiency of the engineering process, but also contribute to the development of safer, more reliable, and innovative mechanical systems.